So in this video we're going to go over vector operations, or essentially the operation of vector addition and scalar multiplication of vectors. So let u and v be vectors in the plane. So the components, we represent them with u sub 1, u sub 2. And for vector v, looks like he's missing his arrow, we represent him with components v sub 1 and v sub 2. So these are the x and the y components. And let c be some scalar. And remember, a scalar just means it needs to be a real number from the real number line. So addition is defined very simply as just, if we take u plus v, we're taking the sum of corresponding elements. So u sub 1 plus v sub 1, comma, u sub 2 plus v sub 2. Scalar multiplication for vectors is defined as just taking the scalar times the vector, and then you really just distribute the scalar into the vector components. So these are the two basic operations. Then you define the negative of a vector, so negative v, which looks like I left my arrows off like a naughty person. So negative v is going to be defined as negative 1 times v, so we define negative vector in terms of scalar multiplication by negative 1, and we just then distribute that negative 1 into the vector components v sub 1 and v sub 2. And then it's pretty traditional to define subtraction in terms of addition and scalar multiplication, because defining addition and scalar multiplication is sufficient to define how subtraction ought to work. So the way we define subtraction, if we take u minus v, we say that's the same as u plus negative v, and we know that that's just going to, the negative v means you distribute the negative 1 into the vector components. So we wind up with u sub 1 plus the opposite of v sub 1, and u sub 2 plus the opposite of v sub 2. And then these are just two real numbers, so we know that adding a negative is the same as subtracting. So it turns out that subtraction happens just the way that you think it ought to. You subtract corresponding components. So if you apply those vector operations, so if we let u, v, and w be these three vectors here, we can say, hey, find 2 times u minus a half of a v plus w. And it's just a matter of applying the operations from the previous slide. So it's going to be 2 times the vector u minus 1/2 of the vector 4, 6 plus w, so just plus the vector negative 2, negative 3. And then we can distribute the scalar using property 2. Just distribute the scalars into the vectors. So we wind up with vector negative 4, negative 6. And then we get plus the vector negative 1/2 times 4 is going to be negative 2, and negative 1/2 times 6 is going to be negative 3, plus our vector negative 2, negative 3. And then the sum is just going to be the sum of corresponding components. So the first component plus the first component plus the first component, comma, second component plus the second component plus the third component. And then you just simplify. So negative 4 minus 4, that's a minus 8, and minus 6 minus 3 twice is minus a 12.